Let me welcome you to the 5th lecture of Drilling and Blasting Technology course, and we are in a position where we are discussing the rock formation of rock, and in last two classes we are being introduced with the rock formed the earth crust, and we are also trying to understand the rock geology a little bit in the last class, and our present objective is that to understand the rock geology, to understand the different rock formation, to understand the rock and rock mass, and to understand the rock mass property. Last class we stopped where we are discussing about the different types of rocks, on which we have discussed the main rock which is forming our earth crust is the igneous rock. So, we know that igneous rocks are formed from the solidification and cooling of magma, and this magma is mainly coming out from the mantle part, and it is a basically partial melt of the pre-existing rocks either in the mantle part or in the crust, and they are coming out as the magma, and this melting of rocks is caused by one or more three processes, namely an increase in the temperature and decrease in the pressure and a change in the composition. So, basically these magmas are coming out from because of these three these three problems, and as it is coming out from the volcanoes and etcetera, it is called igneous rock. Igneous means fire. So, basically what is happened, whenever some increase in the temperature occurs or decrease in the pressure occurs, then what will happen, the magmas are coming out through the cracks in the earth crust or by generating some cracks because of the high temperature pressure onto the crust, creating some cracks, it is coming out through that cracks, and then it is coming out, and then it is coming out from the earth crust to the surface. So, one of the appealing aspect of the plate tectonics is that it accounts for reasonably well for the variety of igneous rocks and their distributions. So, what is happened, so suppose because of the tectonic activities magmas are coming out, then it flows and becomes solidified to form the igneous rock. Simultaneously, these magmas are moves through the cracks in the sides also, and by this movement and because of the high temperature of the magmas, this also changes the properties of these rocks, or sometimes it also melts this rock. So, basically these magmas are coming out, which are basically the molten rocks either from the mantle or from the liquidification of the earth crust material only. So, igneous rocks are divided into two main categories, one is plutonic, that is intrusive, and second one is the volcanic. So, plutonic or intrusive rocks results when the magma cools and crystallizes slowly within the earth crust. That means, in the earlier picture we have shown within the earth crust it is gradually became cooled. So, that is the plutonic one, and the volcanic one, which is coming out, reaches to the surface either as lava, and then it is cooled down rapidly because it is in the atmospheric contact. So, it is cooled down very rapidly, so that it is formed the rock. So, basically igneous rock, it may be plutonic, igneous rock, it may be volcanic, and as the temperature and pressure under which it is became cooled down, so that is why their properties are also very different. Magmas form from which mineral crystallize is rich in silicon, oxygen, aluminum, sodium, potassium, calcium, iron and magnesium elements. So, if it is coming out from the mantle part, the magnesium elements are becoming more. Igneous rock makes up approximately 95% of the upper part of the crust, earth crust, and but their surface occurrences are limited. Mostly it is found in the deeper part of the earth crust, but 95% of the material is igneous rocks. In fact, metamorphic rock is also very similar to the igneous rock. We will discuss about that in the latter part of this lecture, but igneous rock is very different one. It is mostly hard and its excavation is little bit different. Igneous rocks are most of the times having less number of fractures, less number of folds, etc., but igneous rocks are giving somewhat less heterogeneity than the other type of rocks. So, igneous rock makes up 95% and common igneous rocks are granite, basalt, diorite and andesites, rhyolite, kimberlite like this gabbro. These are the igneous rocks, and in general the density of the igneous rocks is generally little bit higher than the other rocks. Sedimentary rock is the next type of rock. When the igneous rocks are exposed to the earth, exposed to the atmosphere and subjected to the atmospheric deterioration like physical, chemical, biological, weathering, in those cases those rocks are changed in the property little bit. Either these rocks are weathered, then removed from that place to the another place and deposited there, that may be a sedimentary rock, or it may be weathered on the same place to form a sedimentary rock. So, this igneous rock disintegrated into boulders, cobbles, pebbles, gravels, sand, even soil, and then they are formed another type of rock, that is called sedimentary rock. So, mechanical and chemical weathering breaks down the igneous rocks in a smaller size particle, and often these smaller size particles are subjected to the subject to the pressure, bed pressure, or some subject to some bonded by some chemical reactions. That way also they can form another type of rock, which is also called sedimentary rock. So, the weathered material transformed back into rock through the hardening process called induration or lithification, thus forming the second major category of rock called sedimentary rock. So, the sedimentary rock is basically formed from the igneous rocks, or maybe 2-3 types of igneous rocks which are chemically jointed or jointed under pressure to form the sedimentary rock. Often it may be jointed under temperature also, but this jointing process must be carried out for the formation of the sedimentary rock. So, basically sedimentary rock is formed under a low temperature, and that is why these are formed from the atmospheric weathering. So, that is why you will find out the 75% of the earth's surface is comprises of the sedimentary rock. However, it comprises very little of the earth crust. So, the deep earth crust, the occurrence of the sedimentary rock is not that much significant, but in the earth crust most of the rocks are sedimentary rocks. Sedimentary rocks are having some particular properties. Most of the time they are occurred as a bedded form, their variations are limited, not like igneous rock variations are high, grade variations. So, like that way sedimentary rocks are little bit weaker rock, their excavation is of little bit easier, energy requirement for fragmenting those are little bit easier, and basically often the sedimentary rock comprises silica also, it may be abrasive also. So, the properties of sedimentary rocks are different. It is very easy to understand the sedimentary rock, it is very easy to determine the sedimentary rock, it is very easy to handle the sedimentary rock. So, sedimentary rock there can be classified in 3 group. This is clastic, where breccia, conglomerate, sandstone, shale etc. are there. This is chemical sedimentary rocks, dolomite, rock salt, limestone, iron ores, these are the chemical sedimentary, and organic sedimentary rock is coal, oil shale, these are some of the limestone are also there, which are coming out from the animals, those are also organic. So, basically sedimentary rock are the 3 types of rock, and most of the times these rock are enriched with some minerals, and often we go for excavating the sedimentary rock for our requirements. Metamorphic rock is more or less similar to the igneous rock, where the igneous rock is or sedimentary rock is changed under high pressure and temperature. So, basically when a igneous and or sedimentary rock subjected to another volcanic activities, or it may be the beds are subjected to under high pressure because of the huge deposition of the rock above that. In those cases, those igneous or sedimentary rocks are converted to the another type of rock, which is called metamorphic rock. So, basically metamorphic rocks are the rocks where the rocks are changed its property because of the high temperature and pressure, and most of the time these high temperature and pressures are applied to those rocks through the volcanic activities. So, these metamorphic rocks are having some different types of behavior, and generally it has been found that their hardness and strengths are more. Above 200 degrees centigrade heat causes minerals to recrystallization, and thus the recrystallization of the mineral occurs from its earlier rock to the metamorphic rock. So, this in combined effect, the recrystallization and reorientation occurs in these metamorphic rocks, and which lead to the foliation of the rocks. The common metamorphic rock which are foliated are slate, schist, gneiss, and non-foliated rocks are like quartzite, marble. So, basically sandstone is the sedimentary rock which became metamorphosed and became the marble. Similarly, granite is the igneous rock which is metamorphosed and became gneiss. Shale is the sedimentary rock which is metamorphosed and became slate. So, basically some sedimentary rock became metamorphic rock, and some igneous rock became metamorphic rock. So, their properties are changes because of the recrystallization, because of the reorientation. So, these are basically changes of the restructuring of the compositions of the material. Now, let us understand little bit about what is the difference between the rock and soil, because the excavation activities are entirely different for the case of rock and for the soil. So, basically soil is basically the weathered rock. When the rock is weathered and it is disintegrated into a finer particle, then in those finer particle again combined to each other, often with the inclusion of the biomass, then resulted into the soil. So, soil is basically formed from the disintegrated rock. So, the basic chemical compositions are more or less similar in the rock and the soil, but often soil is added with the organic material because of the plant and animals residues are coming into that. So, that is why soil is having little bit different property than the rock, and it is as it is a finer is the mixture of the finer particle, its properties are different. So, in a nutshell, if we look into the matter, that we will find, so the igneous rock, this igneous rock that is formed from the metamorphic rock. Igneous rock became melting, then magma is first the magma is coming, it is cooling and hardening, then it is forming igneous rock, then weathering occurs into the igneous rock, then it is become soil and sediments, then sedimentation occurs, sedimentary rock forms. But sedimentary rock may lead to the high temperature and pressure, became the metamorphic rock. Again metamorphic rock may melt because of the volcanic activities and form magma. So, basically the transition from the igneous rock to the magma, igneous rock under high pressure temperature to metamorphic rock, again metamorphic rock through the melting magma became igneous rock. Similarly, sedimentary rock may melt and become magma to form igneous rock, again sedimentary rock can convert into the metamorphic rock. So, like that way different reorientation of the structures, reorientation of the chemical compositions occurred because of the different activities, and the interchanging amongst the rocks are often occurred into the earth crust. Now, let us understand about the properties of the rock mass. The rock mass property, which is basically very important for our drilling and blasting purpose, those are the properties called discontinuity properties of the rock mass. This term discontinuity refers to the joints, bedding planes, schistosity, joints, bedding planes, schistosity, folds, faults. So, these are the basically discontinuities which are considered the dictating the properties of the rock mass. So, fracture or joints, these are the main parameters which is basically the properties of the discontinuities. What is happened if the rock is in the in situ, then it is subjected to the differential pressure, differential temperature load, and because of this differential pressure and temperature, the inherent fractures are occurred there. So, suppose this is a earth crust, a rock is at this position and this rock is subjected to the temperature from the sun, then temperature, seasonal temperature in the summer, winter, then the pressures, differential pressures of the rock layers and other movements on this. So, like that way on different activities the rock is subjected to different temperature pressure and which may generate cracks, tension cracks in the rock mass. Often these tension cracks may filled with some other material also. So, basically this fracture joint, this may be the formation joints also, this may be the induced joint also, this may be the induced fractures also. So, because of this existence of these discontinuities, rock mass behave differently. So, fractures are the planar surfaces along which rock has been broken, causing two separate blocks. A group of such fractures is termed as joint set. If the fractures occurs in a similar manner like this, all the fractures are like this is called joint set. There may be different number of joint sets, one may be like this, another may be like this. So, there may be different number of joint sets, 2, 3, 4 number of joint sets are also very common in case of discontinuities of the rock. Fault is basically occur in the rock mass as a major discontinuity. This is what is happened, a long crack may occur in a rock mass a long crack may occur into the rock mass and that may subject to the displacement of the block. So, this block earlier this block may displaced like this. This block may also displace laterally also. This block may laterally displace also. So, there may be gap, some gap may occur in the continuation of the rock. So, faults are basically the planar rock surfaces along which one side has moved relative to the other side, and this amount of movement is called throw. So, faults are termed as those shear fractures or zones which extend over few meters of distance or more than that. Often there may not be throw also, but fault may exist as a discontinuity plane. So, faults are classified as the deep slip fault, strike slip fault, diagonal slip fault, rotational fault. So, faults are also another very important geological feature to be considered in the rock mass. However, most of the cases if we are interested in the drilling and blasting, the major property which need to be considered is the joint set, not the fault. Similarly, faults are also there, which is basically a wavy form of crystal rock mass and are commonly observed in sedimentary formation, and based on their appearance it can be divided into anticline, syncline, like different types of classification. But the important is that the joint and bedding planes, these are commonly observed and that need to be taken care. Bedding plane is defined as the plane of separation between two layers of different material and also the considered as the stratification plane. The important part of understanding of this discontinuity is the strike, dip and direction of the dip. Basically, strike is the direction of the line that is formed by the intersection of the plane of the rock bed with the horizontal surface. Dip is the angle between the geological surface and the horizontal and is measured in a vertical plane orientation perpendicular to the strike. So, let us have some more understanding on this. So, suppose this is the plan view where a discontinuity plane is existing like this. If we would like to make it a 3D one, say the discontinuity is existing like this. So, the moment we take this out and only look into the discontinuity plane, we will see the discontinuity plane looks like this, and it is understood that this discontinuity plane, if we are looking at the horizontally, this is the horizontal direction and here it is dipping towards this. So, this is the dip direction and the angle which it is dipping is called dip angle. So, basically if some plane, this is the plane is dipping in this direction, this is the strike direction and angle with the horizontal is the dip angle, and this direction is the deep direction. So, this is very important in the rock excavation point of view, where we need to carry out our blasting, we need to carry out our drilling. So, in those cases these directions are important. Generally we use commonly Brunton compass or clinometer for measuring this. A strike is always expressed by its direction, and that may be in 30 degree east, may be like this, or maybe 30 degree east means it is always from north. 230 degree east means it is 230 degree means it is from the north to 30 degree. So, that means it may be in the southwest direction, and this may be the way we can express a strike. Similarly, the dip angle is also mentioned as the degree, and dip direction is always perpendicular to the strike direction. So, if the strike direction is in 30 degree east, then the dip direction, if this direction, say if this is the north, we are considering this is 30 degree, then this is of this direction. So, this may be then this may be 30 degree plus 90 degree 120 degree. So, this may be n 120 degree east. So, as it cannot be the n 120 degree, it is south 60 degree east will be the dip direction. So, this is the most common way we express our strike, dip and dip direction, and accordingly we need to orient our blasting free face based on the direction of the dip and dip direction. So, most commonly if we are having some strike direction like this and dip direction in this, in those cases if you are carrying out blasting, then it is easier for us to explode these materials and we can observe a good blasting in this. However, if the joint orientations are different, then this is very difficult condition to blast this one, as the chances of this portion of rock may not be blasted. So, that is why the direction of dip directions are also very important for our as the rock mass property in rock excavation part, especially in this course where we are dealing with the drilling and blasting. Dip direction is the direction of the dip, is called dip direction, strike and dip are 90 degree apart. So, in next class we will start the drilling technology part. Before that, the understanding, I hope the understanding of the rock as a medium of excavation is now clear to you. Thank you.